My name is Kshitij Dahal and I'm originally from Nepal. And currently I'm master's student in Chinese Academy of Sciences in China. I'm a first year student and today I will talk about landslide susceptibility in Nepal. And I'm not using deep learning for now. I'm using Google Earth Engine and random forest model. And the susceptibility is basically a probability of future occurrence. So it tells what is the probability of that terrain to undergo landsliding. Uh, the first is about introduction. It's yeah, the susceptibility, or this is also called the probability. It subdivides the terrain into zones with different landslide occurrence likelihood. So this is about predicting something for future, and uh, yeah. So in this work, I am classifying terrain as uh, high, moderate, low, and not susceptible. So it's about all about probability. There is a one picture I just found in internet that recent landslides in Lidi, Sindhu Palchuk, Nepal, and in Nepal, this susceptibility is used as a kind of basis for planning of highways and also critical infrastructure. So currently, we do not have a national landslide susceptibility map, and the sustainable spatial planning is difficult. So here I'm trying. So this is just not even an ongoing research. It's about beginning a research. So yeah, here it is. This is the boundary of Nepal, and this is a digital elevation model from SRTM, and the elevation it changes rapidly in Nepal, and the terrain is really slopey. So and these black dots here are the past landslides points. There are only few. I took it from Global Landslide Catalog by NASA in last month, and these are all rainfall triggered landslides. Okay, so these black dots are past landslide points, and I have created non-landslide points. It's random, all random. So in probability, we try to like figure out what is the difference between terrain which has landslide and terrain which do not have the landslide. So there should be some differences, right? So if that differences can be identified, then we can potentially use that to predict future landslides. So this is dependent variables in our machine learning term. And for independent variables, I have prepared 20 variables. I took this from literatures, and these are common things like elevation may affect landslides, and slope, also the aspect, and the diversity and position index, soil moisture, the rainfall, especially when it's a rainfall trigger landslides, and the flow accumulation, and vegetation index, pressure, also the catchment area, and the height above nearest drainage, and these are some independent variables. And I actually did not use all of them. I checked their relative importance using random forest model, and I select this. Like there are eight, yeah, eight variables. This is mean rainfall, this is maximum rainfall, and this is soil moisture, and this is subsurface soil moisture, and okay, this is elevation, slope, and topographic diversity and position index. So this comes from the variable importance. I'll check that later. And this is the overall setup. Like I had this was a animation, and this is the random forest model I use to classify the terrain, and it's about the mapping probability or calculating the probability. And this is the overall setup. So these are the independent variables, sorry, the dependent ones, the dependent variables, landslides and non-landslides. So these are all independent variables. So with help of this and random forest model, so I'm calculating the probability, and now I'm classifying it to like very low, low, moderate, very high, and very high. So these red areas have the higher chance of having landslides in future. And about validation technique, this is area under the curve. And here we plot the false positive rate versus true positive rate, and the area under this curve gives the accuracy. So it's about 83%, which is pretty good. And yeah, I developed this in Google Earth Engine. So because doing for large area like whole country requires a lot of local computational power, and I currently do not have that one. So I choose Google Earth Engine for that, and it's pretty easy here. So everything is just like I upload this landslide point and non-landslide point, and when I just click the run, I can calculate the susceptibility. So this is the probability, and red zones here are like they may have landslides in future. So this is an example case of Google Earth Engine, and here is the susceptibility for whole Nepal. I downloaded it in and make the layout. So this shows the differences. So these green areas are relatively safe, and these red areas, especially about this central Nepal, and this is the lesser Himalaya region of central Nepal. So this is more susceptible. So we may have more landslides in this area in future. So this is relative variables importance. Yeah, I was talking about this before, and uh, it calculates the correlation actually. So we can see this elevation, rainfall, and also the slope, and also the soil moisture are like it correlates with landslides linearly or non-linearly, because I'm using random forest model. So this comes from random forest model, and this is accuracy is about 83%. And yeah, we just had a very disastrous event in Nepal. It is in Melamji. So I was checking about this very recently, and there was a flood. Many people died, and it was flood something that was not expected, and it's because of the landslide outburst flood. So in the upstream there was landslide. So I checked the rainfall there, and the rainfall was not that high. So it was a normal rainfall, but the disasters was like it ha- uh, it has many damages. So I checked this in my susceptibility model, and I find that that area is like really susceptible where the landslide happened. And I also checked the stream power index of the river, and that was also high. So which means that so there is already the probability of landslide, and because stream has more erosive power, so it's common for river to like break this, and so there is a resulting flood. So I find this as a quite common, and we may have such events in future. So maybe I can try to keep this as a field validation. So I'm not sure, but I think this national susceptibility map helps. So the next is this one is very important, and this one is where I want to discuss. And although this work has like good accuracy, but there are a lot of limitations. The first is the landslide data from global landslide catalog are especially inconsistent. So when I try to see the landslide points in Google Earth, so these are not on landslide points. So we maybe I need to create a more robust data set before talking about prediction. And so far the results are only obtained from the random forest model. So the good accuracy I'm showing, maybe it come out by chance. So it may be possible. And I also do not include some really important variables like geology and soil type, because I could not find the promising ones, so I haven't used it as independent variables. And also the uncertainty which may be associated with landslide data. So I already talked about this. And remote sensing product like rainfall and soil moisture, maybe we also need to like correct the biases. uh, and now like I'm trying to for the next step. So I'm trying to detect past landslides. So it's about creating landslide inventory with CNN and Planet Labs images. So far I'm collecting these images, and now I have the images for whole Nepal. But Yeah, about detecting, it's like I'm just beginning. So I'm also like Tanuja shared. I'm also trying to install and getting things started. So maybe in a couple of months or so, I will be able to maybe run my first model, and also I will try to include other machine learning models like ANN and support vector machines, also decision trees to predict and also verify the results. And yes, and try also like thinking about correcting the biases for this rainfall, soil moisture, or other independent variables. So that's pretty much I have done. Thank you very much for listening. And so if you have any comments, I'd be really happy for that. Thank you.
Thanks so much. That was a great presentation. So I'll open up to any questions on the line. All right, that's a healthy pause. I'm gonna hop in now. So can you open up your slides again? I've got a question. So you mentioned that you're grabbing these inventories of known locations of landslides. So maybe I missed it, but where are you grabbing? What's the inventory that you're utilizing?
There is a website by NASA. It's Global Landslide Catalog.
Okay.
So it is like it collects data from crowdsource, I guess, and it provides the data set of the past landslides that happened. So in machine learning, like we use that as a dependent variable. I use that as dependent variable, but there are like a lot of landslides are missing. It's in Nepal, like I guess there are like more than 20,000 landslides, but in catalog there are about 300 landslides.
Hmm.
So yeah, I already told you I haven't done much research. So maybe so for that I am like trying to learn how to detect these landslides with planet images. I think it's possible. So now I'm trying to create and detect automatically, and maybe that will train model better. So that's my plan.
That's great. Yeah, I think that landslide inventory is by Dahlia Kirschbaum and team, and I know that the Surveyor Mekong team is working with her right now. So that's fantastic. That's what I was going to point you to. Here is a 8-meter DEM from NASA as well that might be useful. I know that probably you're dealing with spatial resolution concerns with your random forest approach. So having an 8-meter DEM might be useful. And let's see here. I have a landslide review document up that I'm looking at right now. Oh, University of Durham University. I don't know if you've heard of this group before, but they have an international inventory as well. And they conducted a landslide feasibility study right after the earthquake, I think in 2012. So they have,
15.
yeah, let's see here. Oh, Biplov just shared something. Yeah, World Bank is another great example. So there's plenty of great resources. And then the thing I was going to share is this NASA developed drip and slip model, which is based in Google Earth Engine, which is from Dahlia Kirschbaum's team.
Yeah, I have checked that.
Okay, great. Yeah. So I think that's really fantastic that you're sort of dialed into these resources. And I'll pause here if there's any follow-ups for the presentation.
I just have a quick question. I was wondering how far back the data goes, and what the time period of your study is.
Yeah, thank you for the question. Yeah, currently this probability do not include the time information. It's not dynamic, so it's all about like characterizing the terrain. So if there is calculating if there is a possibility of that terrain to undergo landsliding.
Okay, thanks.
I
Yes.
have a question.
Oh, go ahead, Ate.
Yeah, I think one of the, thank you for the presentation. I think it's very interesting, and I have a question specifically on how you collect the data points on when there is not a landslides, because I think that's in the end one of the most interesting data points, because of course there are a lot of missing data points in your data set, but especially the difference between when a landslide doesn't happen and when a landslide happens, given the variables in your model, to make a distinction between that is very critical in building this random forest model. So how did you select specific points where landslides are probably likely to happen but didn't happen? Or do you have that specific data in your model?
Yeah, thank you for the questions. Yeah, there was like something I was exploring, and for now, just to get started, I took this. So when there is no landslides mark, I took that as non-landslide. So it's random. But recently, I have found a literature. It's from Massimiliano Alveoli, I guess, and they kind of mapped the non-landslide susceptible area in the world. So now I'm thinking about using that data to provide non-landslide points. So maybe I think that would be better, and maybe also increase the accuracy. And yeah, it's really important. And I also see some of the papers using some clustering approaches to create non-landslide points. Also, yeah, I'm also trying to explore that as well. Thank you for the question.
Yeah, that's a good point. So have you looked into maybe doing like a pseudo absence background configuration of like known locations and then doing like 10,000 background points with like a maxent model? Because that essentially, you know, if you're doing susceptibility or suitability to some degree, you're essentially doing some niche modeling, and that might be an approach using maxent. And or and any other algorithm, but doing background points to Ate's point of like, how do you deal with absences when you don't have a data set that's only known locations, right? So you could do either an incident and an absence, or pseudo background and incident, or you need a really good validation data set. So that's one approach. Feel free to reach out to me on that. I'm interested to hear more about your next steps too, and using planet data. I know there's people on the line who've been using planet data for some validation and using it for modeling as a whole. I know people are using NICV data. I'm just going to throw that out there and sort of turn off my mic and see if other people have sort of comments on thoughts of how to take this to the next step with CNNs.
Kshitij, sorry, go ahead.
Sorry.
Go ahead, Nick.
Following up on Tim's comment about the pseudo absences, yeah, that sounds like a good thing to check on. There is a new algorithm in Earth Engine, AMNH maxent, which is specifically for this kind of thing. And if you're going to move into CNNs on, higher resolution imagery, that would be a fascinating comparison in terms of, what more you get from the fancy deep learning models compared to, traditional random forest and maxent kind of stuff. That'd be a great paper.
Sure. Thank you, Nick.
Hey, Kshitij, good presentation. I was just wondering if if it makes sense to include some of the socioeconomic data sets as well, because I know like there are several landslide cases in Nepal where, for example, if there's not a settlement that's got affected by the landslide, or if there is not a road blockage, then those landslide do not get reported in some of the inventory. So I was just wondering, like, if it makes sense to use some of the socioeconomic data sets and see if, for example, you can make a empirical relation between the susceptibility and the effect that it might have on the vulnerable groups.
Thank you for that, Viplab. Yeah, yeah, I was thinking about that actually, and yeah, maybe socioeconomic data, it's kind of dynamic. So maybe I think it. So I like drop it in modeling, and because I'm trying to characterize the terrain, so terrain is usually not much affected, I guess. But like I am trying to like overlay this probable landslide zones with the socioeconomic data. So one thing is that also try to identify the areas where like there are no people, and also the areas where there are people. So maybe the concern will be more focused on the probable landslide zones where the people live. So that's a risk. So maybe I will try to do that. Yeah, thank you for your comments. It's really helpful.
There's the Lhasa model that I just shared from Dahlia's team, and I'm looking back through recent notes, and I know that they're using the GX boost approach. So while you're still sort of in the traditional machine learning realm, doing a comparison with Maxent and to maybe GX boost and random forest, I think is a really, because then you've sort of crossed a lot of the different approaches off in classical machine learning, and then transitioning to this CNN, I think could be a good paper, as Nick had mentioned. I think that there's there's as you're setting this up, feel free to reach out to our working group. I mean, you're part of the working group now too, so you're part of the fabric. So because I know that folks from the Severe Mekong team have been using planet imagery. We've been using it for validation work, mainly, going after the fact to confirm land cover change or, inundated areas. But now we're starting to use it for some transfer learning. So I know you talked about past examples of landslides with the CNN, but, there is something to be said about, I don't want to blow the scope of your project up to something gargantuan, but, the timing of the planet imagery is so rapid that you could be using it to deploy some models to be sort of forward looking or as reactive as possible near real time. So I think that could be an ultimate target for some of your work. I don't know what the compute on that looks like, but I don't know. Planet is, if you have the access to get a lot of that imagery, I think a lot of doors open on what you can do with it too. So as you're on the drawing board, feel free to message all of us, use the Skype channel, and we can put our heads together on, what kind of flow makes the most sense. I know we're nearing the top of the hour, so if anyone's got any more comments, questions, feel free. Well, awesome. Thanks, everybody. And thanks so much for the great presentation. And let's talk in 2 weeks.